All right, we're going to get started. Hello, everyone. Thanks for coming to write your first web data connector. My name is Brett Taylor. I am a staff engineer at Tableau. And with me is my colleague, Ashwin Sakar, at the back. So I've been with Tableau for 6 years. And I've been a C++ engineer for 12. I very recently joined the Web Data Connector platform team. And I was a bit worried. I haven't done any JavaScript since about the year 2000. And at the time, Netscape 4 was the popular browser. In that time, there's all of this new web technology. There's Node.js, there's jQuery, and all of these frameworks that I knew nothing about. So the first thing I did when I joined the team was to build my own web data connector, and this was to the Slack API. Now, the Slack API requires things that we're not going to get into today, things like authentication. But even with my limited JavaScript experience, I was able to get off the ground running and get one built pretty quickly. And that's why I'm excited to be here today at TC, to show you all how easy it is to go and build your own web data connector. And to get started, let's take a quick detour, and I'm going to show you first how easy it is to use a web data connector. OK, here we go in Tableau Desktop. I'm going to go to Web Data Connector and connect to my favorite web data connector, which is called the Movie Database, which ironically pulls data on the top-rated TV shows. I click the Get Data button. It dismisses. It pulls data. And now we have a new data source that is pulling data from this web data connector. I'll go to the sheet. It will create an extract, and we're done. We're ready to go. Let's take a quick minute to have a look at what we've got in this data set. So I'm going to look at popularity and vote count and pull in the name of the show. And we can see that Game of Thrones is very popular. Breaking Bad, one of my favorites. The Big Bang Theory, I've never seen. My uncle likes to tell me all the time that I remind him of the main character. I don't think this is flattering, so I made the same joke yesterday at the talk. This is a repeated session. And today, just before noon, a customer came to the Tableau Labs booth to talk about web data connector stuff, and she told me the same thing. So I don't think this is good. Oops. All right. So Web Data Connector is part of the Tableau Developer Platform. The platform, it enables automations and integrations. It enables embedding your content anywhere, and of course, dashboard extensions. The Web Data Connector part of the platform is part of data connectivity, and that is, of course, where we will focus this dev track talk today. On today's agenda, we will talk more about what a web data connector is. We'll talk more about how to use web data connectors. And then Ashwin is going to come on stage and give us a live demo to show us how easy it is to build a web data connector. So if you've never used one before, you're in the right place. And if you have used one, but you've never tried to build one, you're still in the right place. But even if you have tried to build one, I still think you'll learn something from today's talk. So what is a web data connector? Tableau, it supports connections to all sorts of standard databases, SQL Server and Oracle, just to name a few. And of course, file-based connections, text files and Excel. But on the web, there's all of this data. And that data isn't available in a standard form that Tableau supports. So how do we tap into it and use it in Tableau? Let's start with the architecture. On the left, we have Tableau Desktop. And on the right, we have some web endpoint. Maybe it's the Facebook API. Maybe it's Twitter. Maybe it is some custom web endpoint within your corporate network. It's whatever you want it to be. What we need now is we need some glue to bring these two together. And that glue is Web Data Connector. We provide the Web Data Connector development library. And you can write some JavaScript glue that talks to your web endpoint to pull data into Tableau. At a minimum, all your JavaScript code needs to do is pull data and translate it into the tabular format that Tableau expects. Finally, at the bottom, we have a Tableau extract. And that's because Tableau builds an extract with your Web Data Connector data. Like other extracts, they can be refreshed, both full and incrementally. And of course, they can be published to Tableau server. Now, there are many ways you can connect Tableau to arbitrary web-based data. But here are two good reasons why you should consider using a web data connector. And the first is data accessibility. With a WDC, you can connect to literally any data you can get access to in a web browser. But there are other ways of accessing this data. You could, for example, write a Python script, and you could scrape the data from your website. You could use Tableau's extract API and build your own extract. But these options still have a downside, and that brings me to the second reason. And the second reason is automation. Maybe the data you want to connect to is already in, say, CSV or JSON. Well, you do not need to write a web data connector to access this. You can go to the website, you can download it, and you can load it in Tableau. But the WDC will let you automate the refresh of this data. All you need to do is refresh your existing data source. If you didn't do that, you would have to go and download it again and reload it in Tableau and repeat the process every day or however often you wanted to update it. So let's talk a little bit more about how to use web data connectors. And I'm going to switch again. OK. Let's close this. So if you haven't used one before, to connect to Web Data Connector from the Connect pane, you click on More under To a Server, and you will find Web Data Connector at the very bottom of the list. This loads a dialog, and you might say that it looks a little bit like a web browser. Turns out this is a web browser. You can type in any URL, and it will take you there. First thing I'm going to do is I'm going to click this What's This link. And this will take me to the Tableau Community Forums page for Web Data Connector. I'm going to scroll down, and I'm looking for this Community WDCs link. I'm going to click that. And this page is a list of WDCs that have been contributed by the community by people like yourselves. On this list, at the very, very, very bottom, is the movie database. This is the WDC that I showed you at the very beginning. So if I wanted to use this in Tableau and I hadn't used it before, all I need to do is copy the link here. Go back to Tableau, paste it in, and we're connected. But I've already shown you that one, so I'm going to go back home and I'm going to use one that I've already connected to in this instance of Tableau. It's the USGS earthquake feed. And this WDC is included with the Tableau WDC development kit. You can see the full source for this if you download it. So when I click on this one presents us with a page that has two fields. These fields allow us to filter the data that the WDC brings back. So I'm going to type in 2018-0101 and whoopsies. And 2018-0930, and we will get earthquake data for the first 9 months of the year. Here we go, we're connected. I'm going to pull in the first table that it offers and go to a sheet. It runs the query, it creates the extract. This was a lot faster yesterday. Apparently the Wi-Fi is not speedy right now. Okay. In this data set, we have earthquakes. I sure hope not. We have earthquake data for all of the earthquakes that have occurred this year. And I live in Seattle, so since it's my talk, I'm going to go in here. All right. Just in case I didn't realize, there have been no major earthquakes near Seattle this year. So I think question asked and answered. That's how easy it is to use a web data connector, and that's how you get started connecting to one. I'm going to switch back again. All right. So before Ashwin comes on stage to give us a demo, to show us how easy it is to build one, there's some more background information I'd like to provide. So before we can build one, let's talk about what a web data connector is at its core. It's just a web page. You can build it like any other web page. You can display UI, you can interact with other parts of the web, you can use whatever frameworks you like. But you can also put together a very simple HTML and JavaScript page, and that's what we're going to do today. The conceptual model that you need to keep in mind is that WDC serves as a bridge between Tableau and your content. Tableau will ask your connector for schema information and data, and your connector will get that information from its source. So to build a WDC, we need to build a web page that communicates with the WDC JavaScript library to provide the schema information and the data when Tableau asks for it. And that's it. WDC is just a bit of JavaScript glue to bring together Tableau and your data. How many folks in the room have experience building simple web pages? That's great. And if you haven't, I assure you it'll be pretty straightforward. The next thing we need to talk about is the WDC Phase Model. So your WDC will be loaded by Tableau multiple times. Once for interaction, and then multiple times for getting data. So let's talk about this a little bit more. So the first phase is called the interactive phase. This is where your WDC has the opportunity to display UI, which can be used for collecting filter information, performing authentication, or whatever other steps you need to do to get the user to the point where they can specify the data they want. The second phase is the data gathering phase. This runs after the interactive phase, and it's used to retrieve schema and data. It can be called multiple times because Tableau can refresh your WDC, and it will not go through the first phase when it does that. There are 3 functions that every WDC must implement in JavaScript. Actually, I lied, there's 2, but I'm going to talk about 3. So init is your opportunity to initialize your WDC and specify advanced options, but it is optional. If you have nothing to specify here, you can leave it blank. You don't even have to specify it at all. If you do implement this function, you need to call this init callback argument. This tells Tableau that you're done initializing your WDC. The next function is called getSchema. This is where you return your schema information. So your tables and the fields within your tables. Again, this function takes an argument called schema callback, and you call that at the end of your function to tell Tableau that you're done. This is used here in Tableau Desktop, for example, to enumerate the fields when you select a table. Next is getData. You might be surprised to learn that it's used to get data. It takes 2 arguments, table, which is where we tell you what table to get, and also the done callback, which you use again to tell Tableau that you're done. And it is used in multiple places, but here is an example of one of them when you want to enumerate the rows in the selected table when you're building your connection. And with that, Ashwin will come on stage and give us the demo.
Hello, everyone. My name is Ashwin. I'm an engineer at Tableau, and I'm originally from India. In fact, from one of the most populous cities in India, a city called Chennai. I've lived in the United States for about 8 years in several cities. And this year, when I interviewed at Tableau, my colleagues told me summers here are second to none. I accepted Tableau's offer, and I moved to Seattle. I came here, I decided this is where I'm going to stay. I even bought my first home in Seattle. And just 2 weeks after, this is what I got. Entire Seattle, in fact, yeah, greater Seattle area was covered in thick smoke blankets. some of my colleagues were even working from home, and I saw people running around with respirator masks on the road. The air quality around Seattle is some of the worst in the world at the time. I was thinking to myself, did my colleagues lie to me? So when I went and asked them, is this the good summer you promised? They assured me this was just an anomaly. But I wanted to be sure myself, right? Maybe I should go live in the suburbs where the air quality might be a little bit better. So I started some research on what really the air quality is, what it means. In fact, EPA, Environmental Protection Agency, has a set of air quality standards defined for 6 principal pollutants. Let's focus on one single air pollutant here. It's called PM 2.5. It stands for particulate matter of diameter less than 2.5 micrometers, the size of which is comparable to 3% of a strand of hair, which is tiny enough to get into our lungs and affect it. And safe levels defined by EPA for that parameter is 35 micrograms per cubic meter. So after some research, I decided I'm going to build the WDC myself to help me answer some of my questions. So today, live on stage, we're going to build a web data connector to find out about PM 2.5 levels in Seattle this summer. Let's get started. So before we get started building one, there are some prerequisites that you might want to follow, that you have to follow. The first thing is getting to know your web API. For today, we're going to be using Open Air Quality's API that aggregates air quality data from around the world and gives us that information. So let's take a look at the documentation for that. I'm going to swap here. All right. So here is the documentation for Open AQ Platform API. Now, let's head straight to the measurements endpoint, the interesting one. So the endpoint here gives us data about principal air pollutants. In our case, we are going to need PM 2.5 levels for in and around Seattle. For any endpoint, there should be a section for a sample response. In this case, this is the sample response for the endpoint. Let's see what it has. It has parameter ammonia, okay. It's recorded on so-and-so date, and it has a value of 72.9. And its units are micrograms per cubic meter. It's recorded in India, and it has coordinates information. Sure, looks like we can leverage this information for our connector, right? Now, any API is going to have a lot of data. How do we filter to a data set that we are interested in? Now let's head straight to the parameters section. Every API will have a section for parameters. Now the thing that points right at me is coordinates and radius. So we'll use this to look at Seattle as our midpoint and look 200 miles around it. And even for that area, there's going to be a lot of historical data, right? So we'll be using date from and the date to parameter to filter to look for data only for this summer, right? So these parameters are required in constructing the full API endpoint. I already have it constructed for us, and this is the endpoint here, and this is the response in my browser. Now, that's a clutter, right? I would want to see something more pretty. I generally would use a JSON formatter. In this case, I'm just going to use an online formatter for me that'll format the JSON. Okay, here we go. So all the information that we are interested in is contained in the results object. Now this contains information about PM 2.5 levels for in and around Seattle. Great, so that's our first prereq. Moving on to the next one. The next one is, yes, the tools. Any good software development requires the right set of tools. In our case, we have a few simple requirements. First, you need to download the WDC SDK. Second, you need a good text editor. I prefer to use brackets, but feel free to use whichever is convenient for you. And then third is have a web server ready. In my case, I'm going to be using Node.js, but feel free to use any simple HTTP server where you can host your web data connector. So that completes the list of prereqs that we that we have to build a web data connector. So going back, all right, just give me 1 second. Here we go. So I already have the web data connector downloaded for us, the WDC SDK downloaded for us, and it's over here. Now, I have the API. I have the WDC tools. Now we're ready to start putting together our WDC. Now, I would recommend not to start from scratch. Always start your connector from an example connector. In this case, we'll be using Earthquake USGS example connector. And all of the example connectors are located in the examples folder in the WDC SDK. So I go into the examples folder. The HTML files are contained in here, and the JavaScript files are contained in here. The HTML file, so I go into the HTML folder, make a copy of the Earthquake USGS HTML. I'm going to rename this to openaq.html and open this in my text editor. Open a bit. Okay, great. Okay, and I'm going to do the same thing for my JavaScript file. I'm going to go into the JS folder, make a copy of the Earthquake USGS, and open this in my text editor. Okay. The first thing you do is tidy up your HTML file. I'm going to change the title of the page to say something more relevant about our connector. I'm going to call this OpenAQ Seattle. And likewise, I'm going to change the JavaScript file to point to the one that we just created. Okay. And I'm also going to change the title of the button. I'm just going to say open or get air quality data. Okay. Hit save. And I move on to the JavaScript file. Now, before I talk about the functions, or before I start editing the JavaScript file, I want to talk to you about what this JS file contains. It has 3 typical things. It has get schema. This is where we define the columns in the table. That's get schema. And then get data is where we download the data from the web endpoint and push it to that table object. And then the third piece is simply registering the connector. Now, these 3 things form the backbone of a basic WDC implementation. So I want to quickly go back to the slides and remind you of something. Now, remember seeing the slide before when Brett talked about it, where he mentioned there are 3 functions needed to implement a basic WDC. In fact, we can get a basic WDC up and running in just 2. We can just do get schema and get data. So let's get started with writing get schema. Okay. Now, before we start writing get schema, I would recommend you to have your JSON response on the side while you build your get schema function, because it's super convenient. Okay. And here, we have the columns in the table, right? So this is where we define the columns in the table, so I'm going to have a quick comment. All right? And now these columns, together with the table name, forms our schema. I'm going to go ahead and get rid of all the other columns we don't need for now. Let's focus on one column. So the first thing was we need city. We can start with city, right? On the left, if you look, city, the field city is actually a string. So I'm going to create a column called city. And the data type is going to be of type string. I'm not going to bore you with typing out the remaining columns, so I already have it copied. I'm just going to do a quick copy paste. And I'll go over what these columns are. Okay, so parameter. If you look on the left, parameter is of type string. Okay, great. And then value. Value is a floating point. It's a 66.9 on the left, so it is of type float. And then unit. If if you come down and see here, unit is micrograms per cubic meter, which is also a string. And then date is of type date time. And latitude and longitude are of type float. And if you look on the left, lat longs are of type float. Great. So we've defined the columns in the table. What do we want to do next is simply give our table an ID. I'm going to call this OpenAQ SEA and a corresponding alias. OK? Maybe Seattle. Cool. And then after that, I'm going to tell schema callback of table schema. Now, what does this say? This tells Tableau that we are done getting the schema, and we are ready with the next step. Now, if we have spent a little bit of time coding, we want to test whether this works, right? So I'm going to save this file and test this out in the simulator. So have I told you what a simulator is? No. Great. So simulator is a JavaScript application that is included in your SDK. And that basically simulates the way you load connectors in Tableau desktop. Right. So if you look at the simulator, the first section you see is connector URL. And now this points to, so this is the place where you need to specify where the WDC is hosted. So in this case, it's hosted in examples HTML openaq.html. OK? Now, when I click Start Interactive Phase, it'll mimic Tableau's interactive phase. And when I say Get Air Quality Data, the interactive phase completes, and it pulls up the following information. OK. So we have the table info here. Now, the stuff that you see that points out at us is the alias and description is empty for all of the fields. And that's because we haven't defined one for any of the fields. So I'm just going to go back to the schema part and define an alias and description for the field city. OK, and the description, I'm just going to say some cities. Sure. Save this and come back to the simulator and retest this part. And actually, while I'm here, I just also want to go and change the name of the connection name. OK, let's go back to the schema, save, go back to the simulator, start interactive phase, get our quality data. And as you can see, we have the alias and description populated for the field city. OK, so what have we done so far? We've implemented one of two basic functions, which is get schema. And then now we need to implement the second basic function, which is get data. So going back in here, OK, get data. So the first thing we want to do is change the URL in the get JSON part to point it to our web API. In this case, the Open Air Qualities API. I already have it copied here, the one that you just saw in the browser. I'm going to go back to the JS file and paste it here. OK. And then the next thing is, you see the lines of code here. What does this tell us? This basically tells us the mapping from the fields in our response to our defined schema. I already have the mapping copied for us. So let me copy paste and tell you what it does. OK, here, all it does is it copies the field city from the response to this field city in our schema. Likewise, I'm going to do the same thing for parameter, value, unit, date, latitude, and longitude. All right. So let's look at this together. What happens here is you get the JSON from the web endpoint. And over here, what you do is you go over the response array, and you apply the mapping. And after that, you push it to the table object, and then you say done callback. Now, done callback tells Tableau that we are done getting the data. So I'm going to go hit save and test the get data part in our simulator. I'm going to go back to the simulator and just reload, start interactive phase. Interactive phase completes, comes back in here, and when I say fetch table data, it's going to mimic Tableau's data gathering phase. Oops, we have an error. Let's try to fix this. I am running this on Chrome, so I'm going to be using Chrome's browser's debugging tool, which is in View, Developer Tools. OK, so what is our error here? It says cannot read property length of undefined, and it points to a particular line, openaq.js, line 55. Now it says feet is undefined, and if I go up and see what feet points to response.features. Now, did anyone remember seeing features object in the response? Let's take a quick look at the response again. All right, if you see here, we do not have an object called features, we rather have an object called results, right? So let's go back to the JavaScript file and fix this. All we do is replace features with results. Okay, hit save, you go back to the simulator, you can close the debugger, reload this, and retest this. Did interactive phase completes, and then fetch table data, data gathering phase starts, and it completes. Here we go. We've got our data. Now, what have we done so far? We've done two of the two basic functions. One is get schema, the second is get data. We verified the schema for correctness, and we verified data for correctness. Now, what would you think the next step would be? Well, I didn't tell you what the next step is. So all you have to do is just load the connector in Tableau Desktop and start visualizing. Let's do that now. I'm going to open Tableau Desktop. It's already open. And click Web Data Connector. Now, you would have seen this earlier in Brett's slides, right? Or Brett's demo. So I'm going to load the connector that we just built over here. It's located in localhost 88 examples HTML openaq.html. Right. Now, when I click Get Error Quality Data, just wait for a bit before the connection page loads. And yep. And after this, I'm going to click Sheet 1. When I click Sheet 1, a WDC extract gets created. Here we are. Here's our data. Now, we started on this path of wanting to build a web data connector to find out about PM 2.5 levels in Seattle for summer. And we've got one built, so let's start exploring. Let's start by creating a base map by pulling in latitude and longitude. Okay, this is the greater Seattle area. And I'm going to pull in cities into labels to see for what all cities we have data for. Sure, we have data for almost most of the cities in Seattle. Great. I'm now going to bore you with the details of building the viz, so I'm going to swap to a viz that I already built. Just wait for a bit before this loads. And here we go. So this viz is built from the same data source that we just connected to. Before exploring the viz, I'm just going to go and tell you what the color legends are. So here, the center point, it says 35. So does anyone remember what the value of 35 is? Yeah, it's the safe levels defined by EPA for the parameter PM 2.5. And so here the colors basically mean blue is good, red is bad. So let's get back to the viz and see what's going on. So from my experience, August was the time where people were running around with respirator masks on. And so let's look into the weeks of August and see what's going on. So the week of August 5, the air quality is slowly starting to degrade in central Washington over here. And what happens the next week? the week of August 12, air quality rapidly deteriorates in central Washington, but Seattle still looks safe, right? So what's going on here? What happens the next week? Well, almost entire Washington is hit with bad air quality. And I clearly remember this was the time when city issued warning to stay indoors, right? So looking at this viz, even moving to the suburbs won't really help me, would it? Don't think so. So I was thinking to myself, was this the entire trend of Seattle's summer this year, or was it just a blip? So I built another viz just to see what's going on. And here we go. So the data points that pop right at us is these things, right? The red points here where the air quality has been so bad. In fact, on August 22nd, it's been, the air quality for the parameter, PM 2.5, is about 99. It's way above the safe levels of 35. But then magically, things are back to normal again. So yes, what my colleagues told me is true. It is just an anomaly. And all of this is because of the crazy wildfires in Washington. But apart from that, Seattle summers are gorgeous, and I'm really happy with my move here. Thank you. So that's how simple it is to build a web data connector with which we've explored Seattle's air quality. Now, you could ask me that, sure, I could do the same thing with a JSON connector. Why build a web data connector? Now, what more could we do with this connector? When we built the connector, we used a hard-coded endpoint to look for Seattle-specific data and for a very specific date range. Now, what if user was given the ability to interact with the connector to look for air quality data for anywhere in the world and for any date range? Now, that's possible only with a web data connector. Now, with that, I'll pass it on to Brett to shed more light on WDC.
All right, thank you, Ashwin. That was a great demo. OK, so that's how easy it is to build your own web data connector. And now, I'm going to offer you a few more development tips to help get you started. So the first thing is watch out for differences in browser behavior. Tableau internally uses a browser based on something called Qt WebKit. And it's quite different than Firefox and Chrome or whatever other browser you're using. So this can lead to the situation where it works in your simulator, but it doesn't work in Tableau Desktop. And this is, of course, because you're running in the simulator in any browser of your choosing, and that's different from what Tableau is using. Now, I have good news. We are actively moving to use Chromium internally in Tableau. This means you will be able to more closely match the behavior you see in the simulator in your own local browser, and it also means you'll be able to use standard Chrome debug tools in order to debug your JavaScript code within Tableau Desktop. The next thing is to watch out for state. Don't expect state to be preserved. I mentioned earlier that your WDC will be loaded by Tableau multiple times. If you try and use global variables and you expect them to persist between instances of Tableau, you will find that it won't work. So if you need to pass state, you need to do this using the tableau.connectionData property. Next, if you plan on doing refreshes on Tableau server, you need to take a few more steps. So every WDC must be whitelisted by your Tableau server admin in order to refresh. If you're an online user, you need to use something like the Tableau Sync client in order to do that. There are more suggestions at this link that obviously you can type into your browser. These slides will be available, and it's also on our GitHub page, which I'll have a link to at the end. There are a few advanced topics that we didn't get to today. So just to recap a few of them. We saw in the earthquake WDC, and then in the advanced air quality WDC that Ashwin showed at the end, we can take user input in the WDC and use that for things like filtering. I recommend looking at the earthquake WDC I showed at the beginning, included with the SDK for an example of how to do this in HTML and in JavaScript. Next thing is, if you do build a WDC and you would like to contribute it back to the community, on the community WDCs page that I showed earlier, there is a link. You can click it. We will happily list your WDC on that page. We also didn't talk about how or where to host your WDC. There are many options: AWS, Heroku, GitHub Pages in some cases works. This is beyond the scope of today's talk, but it's something that you may need to consider. The next thing is authentication. Many APIs do require you to log in. This is a screenshot of the Instagram WDC, and it, of course, expects that you will log into your Instagram account in order to pull data from your Instagram account using Instagram. Can I say Instagram anymore? There are a bunch of examples, including this one, of how to do that, how to perform authentication. It's not terribly hard. The examples are a great place to start for that. And finally, multiple tables. Just like most other Tableau data sources, WDCs do support multiple tables. There is a different earthquake WDC in our SDK that provides an example of how to work with multiple tables. Okay, so if you fell asleep, now's the time to wake up. We talked about a lot of stuff today. We talked about how to get familiar with your API. We talked about how to get all of your tools in line so you can build WDCs. We talked about the phase model. We talked about the 3 functions that you need to implement in order to build your own. And now it's up to you to go and build your own WDC. There are 3 things I'd like you to remember from today's talk. The first thing is read our tutorials. They are very, very helpful. The next thing is do exactly what Ashwin did and steal some code. Use one of them from the community or from our examples, copy it, and reuse it. It makes getting started a lot easier. And finally, use the WDC simulator. Debugging JavaScript within the simulator is a lot easier than trying to do it within Tableau Desktop. Data dev resources. The TC developer track content, including today's slides and the WDC that we built today, is available at the following link. I'll leave that up there for a second. As was mentioned on Tuesday, the brand new Tableau developer program is available. It gives you access to APIs and samples and all sorts of other goodies. You can sign up at tableau.com/developer. And most importantly, Tableau's home on GitHub. This is where you will find the Tableau Web Data Connector SDK, which is the last link at the bottom of the slide. Related sessions. So for those of you with a time machine who can go back to this morning, write your, that's my talk. Data and back again. Lessons from shipping WDCs is the advanced version of this talk. That and this talk and all of the Tableau talks will be available on YouTube at some point. So if you are interested in the advanced session, you should be able to track that down. Please complete the session survey. We appreciate your evaluations. Otherwise, thank you very much for coming. We will stick around for questions.